All right, let's just jump right in. Have you ever looked up at the night sky and just wondered? Where does all of that come from? Well, today we are diving into one of the most incredible stories in the entire universe, how a star is born. And we're going to look at this amazing cosmic creation story through the lens of some really recent research with a special focus on an Indian perspective.
So first things first, we got to get our heads around the idea that space, well, it isn't empty, not at all. It's so easy to imagine the gaps between the stars as just a whole lot of nothing, a cold, dark vacuum. But honestly, that couldn't be further from the truth. In fact, it is the exact opposite of empty. Think of it more like a bustling cosmic nursery. It is absolutely packed with all the raw ingredients. We're talking gas, dust, radiation, magnetic fields, literally everything you need to build not just new stars, but whole new worlds too. Okay, so that brings us to the million-dollar question, right? We have all the ingredients just floating around out there, but how do you go from a cold, spread-out cloud of stuff to a blazing, brilliant star? What's the secret sauce? What's the spark? Well, that's what we're here to figure out. So let's set the stage for this whole cosmic drama. We need to take a closer look at these stellar nurseries inside our galaxy. Now, the official science-y term for this cosmic nursery is the interstellar medium, or you'll see it written as ISM. And it's exactly what it sounds like. It is all the stuff that exists between the stars. And listen, this isn't just some passive, boring fluff. It is a major, super active part of our galaxy. And the sheer scale of it is just, wow. The ISN makes up a massive 10 to 15% of the total stellar mass in a galaxy like ours. Now think about that for a second. That is a huge reservoir of raw material just sitting there, waiting for the right moment to create whole new generations of stars. Okay, so we've got this enormous stockpile of material, but it's all spread out. How does it get gathered together? That's the crucial next step in our story. It's not a simple process. It actually happens in a few key steps. It all kicks off with this really spread out atomic gas. Then, over immense scales of space and time, this gas gets channeled into these enormous thread-like structures we call giant molecular filaments. From there, these long filaments start to break up, creating these little, dense, cold pockets known as prestellar cores. This journey from gas to filament to core is the essential pathway for building a star. And I really want to emphasize this point. These filaments are so important. They aren't just some phase it passes through. They are the true birthplaces of stars. It's inside these huge cosmic threads that the real action starts to happen. And to give you a sense of just how big these things are, this is where some fascinating research from India comes into play. Scientists recently found this incredibly long filament, and they named it the Gandratoy wave. Get this. It stretches for an almost unbelievable 2,000 to 4,000 kiloparsecs. And just so you know, a single kiloparsec is over 3,000 light years long. We are talking about a structure of absolutely staggering size. All right, so we've gathered all the material into a nice, dense core. But what happens next isn't some gentle, quiet process. No way. It's more like a great cosmic battle. In one corner, you've got gravity. And gravity has one goal, and one goal only. Pull everything inward, squeeze it, compress that core until it completely collapses on itself. But, fighting back in the other corner, you have the cosmic resistance. Forces like turbulence and magnetism that are constantly pushing back, trying to keep that core from collapsing. So how does this all play out? Well, gravity is just relentless. It's always pulling, pulling, pulling inward. At the same time, you've got this supersonic turbulence creating all these shockwaves. It's super chaotic, sometimes helping the collapse, sometimes hindering it. And then you've got magnetic fields that act almost like a scaffolding, kind of directing the flow of gas, but also resisting gravity's pull. It is a really complex, really dynamic dance between these incredibly powerful forces. But in this epic tug of war, eventually, gravity has to win. And when it does, when that core finally collapses, that's the moment. At the very center of it all, a protostar ignites. And that ignition kicks off a process called accretion. The best way to picture this is like a giant cosmic whirlpool. The brand new protostar is sitting right at the center, and it just starts pulling in all the surrounding gas and dust from this swirling disk around it, gaining mass like crazy. But here is where it gets really weird and kind of counterintuitive.
As this baby star is feeding and gobbling up all this material, it's also shooting stuff back out. It blasts these incredibly powerful jets and winds back out into space. This is actually a super important step because it helps get rid of excess spin, allowing the star to keep collapsing and growing.
And this is where we are right at the cutting edge of what we know. In fact, a recent scientific paper put it perfectly. They said that the detailed physics of this whole cosmic give and take, the gas flowing in and the material being shot back out, it all remains a mystery. It's one of the biggest unsolved puzzles that astronomers are trying to crack right now.
So, a star is born. Amazing. But the story doesn't stop there, not by a long shot. The birth of a star has this huge, lasting impact on its entire galactic neighborhood. So let's talk about the real heavyweights of the cosmos, massive stars, the ones that are more than 8 times the mass of our own sun. You might be surprised to hear this, but they make up only 1% of all stars. They are incredibly rare. But that tiny 1%, man, they punch way above their weight. These massive stars have a totally outsized impact on everything around them. Their powerful stellar winds and intense radiation can either kickstart a whole new generation of star formation or shut it down completely. And when they die in a spectacular supernova, they seed the entire galaxy with the heavy elements needed for planets and for life. They are, basically, the galaxy's primary engines of change. And what about all that leftover material from that cosmic whirlwind we talked about? Well, it doesn't just go to waste. It settles down into what we call a protoplanetary disk. And this, right here, is the birthplace of planets. Which brings us right back to the beginning. We started with some diffuse gas and dust, and we've ended up with stars and the potential for entire new worlds. So it leaves us with one last big question to chew on. If this is the universal story of how stars come to be, a story of collapse, of conflict, and ultimately of creation, what does that tell us about our own origins? Every single atom in your body was forged inside a star that lived and died long before our sun ever existed. We are, quite literally, made of stardust. Something to think about the next time you look up at the night sky.